Today's episode takes us inside three very different frontiers of AI: production-grade agent evaluation, real-world failure diagnosis, and next-generation reasoning models. We'll look at how one benchmark turns messy business requirements into rigorous tests, how another system uses LLMs to pinpoint integration test failures from sprawling logs, and how a massive hybrid MOE model pushes the limits of agentic reasoning, long context performance, and deployment efficiency. Together, these papers reveal where AI is succeeding, where it still breaks, and what it may look like in the real world. Let's explore the first paper, Alpha Evo Evaluating Agents in Production. Alpha Evo is a production-grounded benchmark built from 94 tasks sourced from 7 companies across 6 O-Times.net domains: human resources, finance and investment, procurement and operations, software engineering, healthcare and life sciences, and technology research. Its core novelty is a requirement to benchmark pipeline that converts authentic, underspecified business requirements into executable evaluations through partner engagement, month-long requirement elicitation, task formalization into query.md, task.yaml, rubric.py, and 3-4 iterative validation cycles with domain experts. Unlike retrospective benchmarks such as SweBench or Web Arena, Alpha Evo preserves production constraints, implicit rules, fragmented multimodal inputs, long horizon deliverables, and evolving stakeholder judgments. The benchmark uses 4 evaluation paradigms: reference verification, formal logic verification, rubric-based assessment, and execution-based verification combined within a single task. Every task uses at least 2 leaf evaluation types. Averaging 2.8, the benchmark represents 2,420 hours of expert-calibrated labor valued at $154K, $231K, evaluation of 14 model scaffold configurations across 6 frontier models and 4 commercial agent products shows a large research production gap. The best system, Claude Code plus Claude Opus 4.6, scores only 64, 41 over 100. Scaffold choice is nearly as important as model choice. The same Opus 4.6 model drops from 64.41 on Claude Code to 53.45 on Codex, and 1 point spread. GPT-5, 2 varies by 15 points across scaffolds. Domain variance is extreme, from 62 inches technology research to 30 inches human resources. Translating scores into labor value changes agent ranking, the best configuration delivers an estimated $110K, $165K of human work, while the worst delivers $70K, $105K. Error analysis identifies 6 production-specific failure modes invisible to coding benchmarks: cascade dependency failure, subjective judgment collapse, information retrieval hallucination, cross-section inconsistency, constraint misinterpretation, and format compliance failure. Let's explore the second paper, LLM-based automated diagnosis of integration test failures at Google. The paper introduces AutoDiagnose, an LLM-based system for root cause diagnosis of Google Hermetic functional integration test failures from heterogeneous logs spanning test driver and SUT components. Its main novelty is not fault localization in code, but log-centric diagnosis integrated directly into Critique, Google's code review system, where it posts findings in context and in time. AutoDiagnose concatenates info and higher logs, sorts them by timestamp, and prompts Gemini 2.5 Flash with a highly constrained instruction template that enforces stepwise reasoning, strict output formatting, and explicit use of component metadata. The output is post-processed into linked log-line summaries. On 71 randomly selected real failures from 39 teams, 3 expert evaluators judged 64 diagnoses correct, yielding 90.14% root cause accuracy. The failures were non-trivial. The median test had 16 log files and 2,801 log lines, with a mean of 26 files and 11,058 lines. At Google Widescale, AutoDiagnose ran 224,782 times on 52,635 distinct failing tests across 91,130 code changes and 22,962 authors. Median time to post a finding was 56 seconds. P90 was 346 seconds. User feedback on Critique showed 517 total feedback reports, only 5.8%, not helpful, and a helpfulness rate of 62.96%, ranking the tool Hasson 4 out of 370 finding posting tools. The paper's key empirical finding is that LLMs can parse semi-structured, noisy, multi-file failure logs effectively enough for production deployment, and that workflow integration matters almost as much as raw accuracy. A secondary result is diagnostic value for infrastructure. The manual evaluation uncovered 2 logging bugs where crash test driver or SUT logs were not saved. Let's explore the third paper. Nemotron 3 Super Open Efficient Mixture of Experts Hybrid Mamba Transformer Model for Agentic Reasoning. Nemotron 3 Super is a 126B parameter hybrid Mamba 2 attention MOE model with 12 7B active parameters per forward pass, trained for agentic reasoning on 25T tokens, and post-trained with SFT plus multistage RL. Its main architectural novelty is latent MOE. Tokens are compressed from hidden size 4096 into a 1024 dimensional latent routing space, reducing routed weight traffic and all-to-all communication while expanding expert count to 512 and activating top 2 experts. The model also adds shared weight multi-token prediction heads, enabling native speculative decoding and periodic attention anchors inside an 8-layer Mamba-heavy stack to preserve global interaction at long context. NVIDIA reports stable NVFP4 pre-training at full scale, with the final model supporting up to 1M context. On base benchmarks, Nemotron 3 Super outperforms Ling, Flash, Base, 2, 0, and GLM4. 5. Air, Base on MMLU Pro 75.65, GPQA Diamond 60, Math 84.84. AIM 2024 passe @3.5.33, Human Evil 79,4, and Ruler on M71. In the post-trained model, it reaches SWE bench 60.47 with open hands, terminal bench core 2, 0, 3, 1, 0. Tall bench V2 average 61.15, and ruler at M, Enohalfems, Sex Sphere, while remaining competitive with Quen 3, 5, 122B, A10B, and GPTOSS 120B across reasoning, chat, multilingual, and tool use tasks. The agentic gains come from expanded RLVR across 21 environments, SWE-RL in containerized repositories, RLHF with a principle following GenRM, and Pivot RL style reuse of offline trajectories. For deployment, the paper introduces mixed precision PTQ using model optimizer and auto-quantize, producing FP8 and NVFP4 checkpoints. The NVFP4 model retains 99.8% median accuracy relative to BF16, while the published throughput claims reach 2.2 times over GPTOSS 120B and 7.5 times over Quen 35122B on 8K input, 64K output workloads. That's a wrap on today's AI paper highlights. Thanks for watching.